Have you ever wondered how programmers take a really complex idea and turn it into a working app? Well, I'll tell you, it's not magic, and it definitely doesn't start with code. Nope, it starts with a plan. Today, we're going to pull back the curtain on the most important planning tool a programmer has: pseudocode. You know the feeling. We have all been there. You get this amazing idea. You fire up your computer, open the code editor, and you're met with that blinking cursor on a blank screen, just staring at you. That feeling of being totally paralyzed, not knowing what to type first, that's exactly what we're going to solve today. I mean, think about it. You wouldn't try to build a skyscraper without a blueprint, right? Of course not. It would be chaos. The exact same idea applies to software. A solid plan is what separates a project that's a total headache from one that's a huge success. So today, we're going to learn how to create that blueprint for any program you can imagine. But, before we can even draw that blueprint, we need a recipe. We need a clear, step-by-step set of instructions. In the world of programming, we call this an algorithm. It's the core logic, the absolute heart of how we're going to solve our problem. So how do you actually write that recipe down? Well, that is where pseudocode comes in. It's not a real programming language. It's more like a structured way to write out your algorithm in just plain, simple English. This lets you focus purely on the logic, the what, without getting all bogged down in syntax, which are all the picky grammar rules of a real programming language. Okay, so theory is great and all, but let's make this real. Let's actually see it in action. We're going to follow a simple idea all the way from start to finish and see exactly where this blueprinting tool fits into the whole process. Every great project starts with just an idea, right? Often it's just a scribble on a napkin or a simple sketch. For programmers, that sketch is often a flowchart. It's a visual map of the program's steps and all the decisions it has to make. It gives us that really important, big picture view of what we actually want to build. And this right here, this slide shows the whole journey perfectly. So over on the left, you've got the flowchart. That's our initial sketch. Then, right in the middle, that's the pseudocode. See how it's more detailed? That's our blueprint, translating the visual into logical steps. And finally, on the right, you've got the Python code, the finished skyscraper, built precisely from that blueprint. So here's the bottom line. Think of it this way. Pseudocode is for us humans to think and plan. Program code is for the computer to actually execute. You can't run pseudocode on a computer, but you really can't build great, reliable code without it. Okay, so every blueprint has its own language, its own set of symbols and terms, right? So now let's learn the basic language of pseudocode so we can start reading and even writing our own blueprints. First thing we need to know is the variable. The easiest way to think about this is like a labeled box where you can store a piece of information. You give it a name, maybe something like username or player score, and inside that box, you can put different things, like text or numbers, or even a simple true or false value. All right, so we've got these empty boxes ready to hold our data. But how do we get information from a user, someone typing on a keyboard, to actually put into those boxes? It's actually super simple. We use a command called input. As you can see right here, the pseudocode for take the user's name as input is literally just input name. That's it. It clearly states our plan. Get some data and store it in our variable box called name. Okay, so we've got information coming in, but what about the other way around? How does the program talk back to us? How does it show us a result or a message on the screen? Well, for that, we use the output command. And as you can see, you can do a couple of things here. You can output a specific piece of text. Programmers call this a string, just by putting it in double quotes. Or you can output whatever value is currently inside one of your variables, like final score, by just using its name. No quotes. But what if we want to get a little fancier? What if we want to combine things? For example, how would our blueprint show that we want to create a personalized message? Something like, "Hello, Sarah." This is called concatenation. I know, it's a big, fancy-sounding word for a really simple idea. It's just joining strings of text together. For example, just like the slide shows, foot plus ball becomes football. Simple as that. Now, in your pseudocode blueprint, you might see a comma, a plus sign, or even an ampersand used for this. They all mean the exact same thing. Join these pieces of text together. The reason you see different options is just because pseudocode is flexible. The symbol you pick often gives a little hint about which programming language you plan on using later on. So, you might be sitting there thinking, okay, I get it, but this seems like an extra step. Why bother with all this planning? Why not just start coding? And you know what? That's a fair question. And the answer is pretty simple. A solid blueprint always makes for a better, stronger final product. Here's the deal. Pseudocode is a programmer's best friend. Seriously, it makes your plan easy for anyone to read, not just other coders. It lets you focus on the logic so you can spot problems in your thinking before you've even written a single line of real code. And the best part? It's language independent. That means the same logical blueprint you write can be used to build a program in Python or Java or C++, pretty much anything. So you see, pseudocode is way more than just a planning tool. It's a way of thinking that can help you break down and solve any complex problem. It frees you from the paralysis of that blinking cursor. So the only question left is, now that you have the blueprint, what will you build first?